Okay, so here comes my favorite way. Okay, so here's the big idea. We've got 6 red and 6 blue marbles. And we're going to draw out, right? We're going to draw out 6. We want 5 red. Okay, so let's so we know we can't use binomial theorem. So you could imagine making a tree, and again, it would just be too complicated to literally make it all, because you'd have 6 branches, it just would be too much. So let's sort of see if we can generalize it. To get one winning branch, how do we win? We want 5 red, 5 red, and 1 blue. So let's just imagining this happening. We would have 5 red, and then we pick 1 blue. This is not the only way. This is one particular way. Imagine going red, 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 and then blue. Okay, so let's see. So we'd have 12 marbles, and then we'd have 11, and then we'd have 10, 9, 8, and then 7. Okay, and then we're picking the 5 red. So first there'd be 6 to pick from, then there'd be 5, then there'd be 4, then there'd be 3, then there'd be 2 left. And now we have to pick a blue. And so all 6 blue are left. So here's this 6. So we have all of this. But we need a counter. Okay, so let's think about what the counter would be. Okay, it's just like when we did the binomial theorem counter. We're doing 1, 2, 3, 4, 5, 6 things we're picking from. And we want to choose 5 of them to be red. And so when I did this on my calculator, I just typed really quickly. I got that this is worth 3 out of 77, which is about equal to 0.039, which sort of matched our last question. It's a little bit smaller. It's harder to get all those red ones when we keep on taking them out of the bag and not putting them back. Okay, but so this is always a done deal. If you can imagine a tree, this is the tree part. You're imagining one branch down the tree. But then the bummer is you have to try and figure out a counter, and that sometimes is hard. Okay, so sometimes you can use this other idea. Your book calls it using combinations, but I like to call it partitioning. Okay, so here's what I want you to imagine. If we were all together in North 317, we would literally do this. I want you to imagine you're looking at the floor of our classroom, and I say, hey, we're going to send somebody from your team out into the hall, and we're not going to tell them exactly, we want to make sure they can always pick a winner for us. So winner is, we have to pick out 5 reds and 1 blue. So how could we partition all those marbles? Let me hang on. Look, I'll use eraser. Look at me. All right. Okay, I'll write meter for you guys. Okay, so we are going to partition. I'm going to say imagine partition. Okay, let's imagine you walk into the room, and how can you put the marbles so I can tell somebody how to pick a winner? Well, you'd say, oh, Miss Brady, over in one pile, put all of the red marbles, right? And over in the other pile, put all of the blue marbles. And then if you walk into the room, here we are, North 317, we miss you. Walk into the room and go to this pile. And you say, Miss Brady, I want from this pile for you to grab out 5. Just grab out 5. I don't care the order you pick in. Oh, that's a combination. So out of that pile of 6 marbles, go and grab out 5. And then I say, okay, Miss Brady, walk over to this, and out of that group, and there's 6 in that group, how many do I have to grab out? I just have to grab out 1. And since every way you grabbed out these marbles, you can match with every way you grabbed out these marbles, we know there's a timesing in between. Okay, so that's how you could pick a winning set of marbles, right? The winning set has 5 reds and 1 blue. But let's just use our old-fashioned how we start a probability, and let's divide it by how do you pick any set at all? Maybe it wins, maybe it doesn't. So I know that I've got 12 marbles, and I'm going to have to grab out 6 of them. Okay, let's see. So this number is 6 choose 5 is like 6 choose 1. The way you can grab out 5 things out of 6 is the same number of ways you can leave 1 behind. So that's 6. 6 choose 1 is 6. And on my calculator, I did 12 choose 6, and I got 924. And when I reduced, 3 out of 77, which is the same answer. But to me, if I can partition a set, that's awesome. Sometimes I partition and still need a multiplier, but we're going to work on some problems next.